Hi everyone, I'm very excited to be here today because first of all, it's my first international conference, and also as Django is continuously amazing me, this is a subject I've stumbled upon not long ago, and I'm eager to share with all of you here. This talk came up from a challenge with a project I work on, which is pretty big, like some tables have more than 10 million records, so optimization was required. And as we use Django, we have to do a lot of, use a lot of resources from it, and one of the things we use it the most are query expressions. All right, so I'm Vanessa. I'm from Recife, Brazil, the red mark there, so I've come a long way to be here today. Also, I work as a software developer at Vinta. And I am a Young Girls organizer at my hometown. And also, I was part of the first female majority hackathon in Recife, which is called Hack Girl. And okay, the bold text in blue is my Twitter handle, and I'm gonna post the slides there right after this talk. So if you have any questions, comments, or general feedback, please feel free to reach me there. Okay, as I said, I work at Vinta Software. We are a product consulting company from Brazil, which works with our clients mostly from the Bay Area and New York to evolve the product using top-notch technologies and UX and development techniques. We work mostly with Django and React. We also love open source, so we have a lot of tools on GitHub that you can check. At github.com/vintasoftware. We've got a playbook as well. It's the last slide, I promise, with all our processes and learning so far, so you can check it out on our website. It's pretty cool. All right, so before I start, I want to give some disclaimers. So this talk is about Django, so I assume you already have some knowledge about it and some concepts, to better understand what we're gonna talk about. Also, I won't be taking questions now, but I'll be here all around all day, so I'm gonna be happy to answer any of them here personally or in any of the social networks. So on to the topic. We're gonna talk about query expressions today, but first I want to ask you all a question. Have you ever tried to fetch complex data in an application and got really confused? It's like a rhetorical question, almost. It's happened a lot to me, and I can only imagine how many times it has happened to all of you here. So as I use Django in my day-to-day, I've thought some time ago that this framework is like 14 years old, so a lot of people use it. So it must have something to help me get whatever I want. So with changes, I've worked with applications that grew large over time, such as the one I work on currently. So we changed on business rules and context. It became very common to create some redundancies along the way, and with that, more and more fields in the database than we actually needed. So that's a reality of a lot of systems out there. And to mitigate problems like this, some people follow paths such as caching or denormalization. And by the way, if you are interested in the subject, denormalization, there's a great talk about it by Flavio Juvenal. He's one of Vinta's partners. You can check it out on YouTube. Here's the title. But if your application isn't really complex and doesn't need the mentioned advanced techniques, you don't have any excuse not to use Django's ORM and to do your queries, and we're going to learn why and how today. But we can't start talking about query expressions without explaining and introducing this powerful tool called ORM. As you may know, in Django, we have the ORM, which stands for Object Relational Mapping. In few words, it's a tool to translate our, most of the time, relational database dialect into Pythonic objects named models. So we have person here. And so they become more readable and manipulatable. So it has lots of useful things that we can use to search for something in our database, such as filter, which we're going to use a lot today. And with it, we have lots of abstractions to help us to get our data much more easily than just writing pure SQL. So today we're not going to talk about simple filters in Django. We're going to dive into some concepts such as QNF objects, database functions, conditional expressions, and present the many ways in which you can appease your advanced query needs with Django built-ins and nothing more. And all of that, for all of that, we're going to be using query expressions, which are smart yet straightforward functions that can be used to compute values on query execution. So, for example, you can do complex queries with OR statements or negative statements, or maybe both if you want, string manipulations, calculations, and so on. Everything at the time Django hits the database. So this removes the necessity of having extra columns there and helps to generate optimized and readable queries. So for instance, with a database of 500,000 records, to get people who were born in a leap year instead of writing the SQL on top, or maybe the naive code on the left, which run, by the way, in an average of almost 4 seconds, we're going to write the code on the right, which run in an average of 0.32. And for that, we're going to be using the query expressions learned today. So to start with them, we need to understand more about queue objects, because they are the most common solution. So if you are familiar with Django, you must have used it a lot. And they are usually the first contact one has with complex filtering, because the API is really not too difficult to understand. And also they serve as an SQL encapsulator for queries with different conditions. So if you want to do like queries with OR statements or negative statements, queue objects are what you're looking for. So to start with a simple example, if we want to fetch people who were born in different generations, one generation or the other, we can do things like this. We can pass each one of our conditions into queue objects. By the way, we're going to searching for birth date. Year is a transform that's going to extract the year from the field. And we're going to use range and encapsulate one of our conditions into queue objects and separate them by a vertical bar. So it means that we're going to search for everyone in this range of years or this range of years. And Django is smart enough to generate the SQL for us. In case you want to add more conditions, it's possible to compose complex filters with queue objects as well. So remember our first filter by years? Now we've added it into a queue object and appended another condition. So this will filter by anyone who was born in one of these ranges of years and lives in California. So to include more conditions, you can just nest them into queue objects and use the operators ampersand or vertical bar, and Django is gonna search for you. Just a tip, because it's very extensible, complex filters with queue objects can get huge over time. So I know that some people say that your code is self-documenting, but it's advised to comment just a little bit so you won't lose time trying to understand the code you wrote a year ago, how that works currently. And as I said before, you can add as many filters as you want. So we've added to our previous example, blood type, job title, and such things. So moving on, let's say that our application has an interface that users can search stuff. So, and the user can input whatever they want, and we're gonna search for all possible fields using insensitive contains for all possible fields. And that would work, but what if the user wants to search just for like job title or just for the first name? We can give our user the freedom to search for everything they want. And that's possible if we mount a queue object before doing the query using an approach with some ifs and queue.add. So it will check, in our example here, it will check which fields the user has selected and add the conditionals accordingly. So, for example, as you can see, email field was not included in the user search, so it's not going to be included in the queue query. So this filter is going to find, for example, people with Mark or as first or last name, people which works as chief marketing officer or trademark attorney, and so on. Just a quick off topic. If you are more familiar with SQL and want to see what your database reads, you can print your query with doing the query.query. And you're going to see the output below in SQL. In this case, for Postgre databases. And I've omitted some info just for simplification as well. If you also want to format it, you can use a lib called SQL parse. It's a Django dependency, so it already comes with Django when you install it. The point is that it's important to understand that at the end, everything's SQL. It took me some time to realize that. And you can see that Django handles everything for us, so we don't have to worry about writing super long SQL statements, which is not the case now, quite the case now, because we have very simple examples, but that becomes a reality on your application skills. Another base resource which is very useful is called f-objects or f-expressions. And to start with it, I want to show an example first. According to the American Red Cross, people can donate blood every 56 days. So we have our person model here that you already know about, and we have less donated and can donate on fields. And theoretically speaking, let's say that when less donated gets updated, we should update can donate on with like 56 days ahead. If you want to get people, and if you want to get people who can already donate, you could do a simple filter like this. The can donate on is least than or equal now time. But what happens if the less donated field is updated but can donate on is not for any reason? How can we assure that this field has a reliable value? Because it's critical. We can't let people donate blood before the 56 days. So this code could cause serious inconsistencies. And to solve problems like this, you will have to use f-objects because the value would always be correct because it will always be calculated on query execution. And f-objects are used when you want to reference a model field or an annotation you made in a query without having to load them into memory, without having to load the field's value into memory. So you can do basic arithmetic operations on query execution. And for example, as I said, people can donate blood every 56 days. So to know when they can donate again, we could do something like this, like annotate the can donate on with F to get our date time field, and add like 56 days with time data, for example. Without it, you would have to write the raw SQL or filter with just Python, which, as we saw in the beginning of this talk, decreases performance a lot. So because there's no such way to do queries like this without using F in an effective way. We can also use F to do operations with different fields or to reference annotations, as I said. So from our last example, we annotated the exact date in which people can donate blood again using F and time data. But now we're going to use F for everything. And let's say that we run a blood bank, and we want to get how many bags are missing for our goal. And to do that, we're going to use the annotation of how many blood bags we have currently, and reference that annotation and subtract from the field goal. So we're going to have the remaining amount of bags that are needed. In our example, 500. So in the previous example, we've used F with two fields, but both were integers. So in case you want to do operations with different field types, you have to use something called expression wrapper. Because when you do operations with fields with different types, Django throws like a field error saying that you must set an output field. Because like start at, it's a datetime field, and duration is a duration field, so it's a time data. So that's solved by wrapping our sum in an expression wrapper and setting the output field as a datetime field. So for example, if we have a day event that starts today and has like a duration of 1 day, this annotation should have today, Monday, tomorrow, same time. And at the end, we can mix F and Q objects all together to create like unique queries. So in this case, we want to get people whose first name equals their last name and don't have Mark in their job titles. I have nothing against Marks, okay? It's just an example. And okay, as you can see, query expressions are very modular, just like some resources that we're gonna see soon. We've seen how to create filters, how to access and do operations with different fields. And now we're going to learn how to manipulate data using database functions. There are basically some abstractions to help us to access database functions, as the name suggests, directly. So for example, to count how many pets we have in our system, we have to use a function called count. So in an annotation, so the value would always be available. In this case, when you use count, it's the field name you pass under the database function name. So we annotated count here. So it's going to be type under count. And in the end, we have the distribution of our pet types easily. And there are more than 50 database functions, I guess. So we're not going to cover them all today because of the time, but we're going to see some of them and see how useful they are. Database functions used with annotations are a very important resource, especially when performance is needed. So another good example, we have our person model, and it has first name and last name field. And I want to search for a string in their full name. So adding a property in the model would do the work, but I just have to load the person on the right, as you can see, and do the search in their full name, and that will work just fine. But there's a problem here. Since it's a property, it cannot be used in queries. So if I wanted to do searches in everybody's name in this scenario, that would not work. I would have to load everyone's name in the memory. And that's not what I want. So a solution to that relies on a NULL function called concat, which stands for concatenation. So you can annotate the full name by calling this function with the field names. So just so you know, I had to put like value. I have to use a function called value in the middle, because if I had put just the empty string, Django would try to find a field named empty string and would maybe throw an error. And after annotating the full name, I can use as many string lookups as I want, and it will work just fine. Just so you see, I wanted to bring this GIF to compare our solutions with the full name property and the annotation. So at first, it's very fast, but as I add more zeros to my limit, the worse it gets. So the last frame was 500,000 records and took about 4 seconds to load everyone's full name. In a big application, such as the one I work on, that's too long for the end user, and we can't let this happen. And back with our full name example, here's a tip. To avoid calling the whole annotation every time you want to like annotate the full name in our example, you can add the annotation to a query set or manager method. We're going to use query set just for simplification. And then add the query set to the model using inside the model objects equal your query set name dot as manager. And now you won't have to worry about wherever you have person model, you can annotate the full name just calling a method. Another great example is a database function called coalesce. It returns the first non-null value given at least 2 field names. So for example, our person model has a nickname field and a first name field. So I want to, like, if they have a nickname, I want to show it. And if they don't, I want to just show the first name. And that works, but there's a pitfall here. And as a sec, coalesce returns the first non-null value. So if someone has, for any reason, empty string as a nickname, coalesce will return it. So that's not what we want. And a solution to that is using another database function called NULL if. It was added in Django 2.2, and which accepts like two expressions and returns none if they are equal. So in our case, we are comparing nickname field with the empty string value. Again, I had to use value because if I hadn't, it would try to compare two fields. And that's it. You've seen that we can do some conditionals with queries, conditional queries with like null if, for example. But if we want to do some complex queries with just one turn to the database, we can use conditional expressions. They allow us to use conditional logic in queries. That means filters, updates, annotations, and such things. Without them, we would have to use Python, and the code would be bigger. And so, from our last example, let's say that people can order things, and let's give them discount for these orders if they are like loyal customers. So using the orders for today, let's get if the user joined our system this decade. In this case, we're going to give them 20% discount. In case they joined between 2000 and 1995, we're going to give like 40% discount. It's 0.8 and 0.6 because it's subtracted from the full value. And we can understand this code, but it's not really too easy to read. A better way to do it will be using case and when expressions. Case is very useful because you can do ifs, elifs, and elses into a query in little to no time. It's better because the value is calculated at the time the query executed, so it will be much faster. And if you want, you're going to be able to like filters, do updates at database level with just one turn and hitting once. And as it's an annotation, we're not gonna lose the original order total. And at the end, we can mix everything we've learned to annotate. If someone birth year is a leap year, for example, just to give some context about how to calculate a leap year, it should be exactly divisible by 4. If it can be exactly divisible by 100, it's not unless it's exactly divisible by 400. It's a bit tricky, but just so you get the idea. So we start by doing the needed annotations with database functions, cast to transform the value from extract year into an integer, because extract year at database level returns like a double precision floating point. I've never personally used that, but that's what the error said. And F object to do the operations with reference annotations, because we want to get like the modulus of the integer. And then we're gonna use the previous annotation into a conditional expression with kill object. And in the when, the second line, as you can see, we define false by default, and then we do all the math to make it true. And finally, we're gonna filter by an annotation we just did, and from now on, it's just testing if it's true. So at the end, we'd have done calculations and conditionals, just hitting the database once. So it's pretty cool. So these are the references that helped me to inspire me to do this talk. There are no links here, but I'm gonna post the slides in the Twitter, on the Twitter, so you can check it out there. And that's it. Thank you so much.